Ladies and gentlemen, Alan Haynes.
Hi, yes, my name is Alan Haynes. I'm the Service Coordination Hydrologist here at the California-Nevada River Forecast Center. I think we're really fortunate in California, especially in Sacramento, to have so many agencies working on this problem, of trying to figure out what's going to happen hydrologically and getting the message out. And I want to echo, what Brooke said earlier about you guys, how important your job is, because I mean, a lot of people don't even know that the Weather Service does hydrologic forecasts, river forecasting, and you seem to all be dialed into getting that information, where to get it, and who to call. We're going to help you sort that out if you have any questions about that. But you have a really important job, and so I just want to basically cover kind of who we are with the River Forecast Center. We've talked a little bit about how we got here in terms of weather and hydrology, but maybe I'll emphasize more what you can expect for the rest of the spring, and then how you can monitor things and get information. And I think what we want to spend some time on any questions you might have. So just in general, River Forecast Centers, the Weather Service has 13 of them across the country. Where we have all of California, Nevada, a little bit of the headwaters of the Klamath River up in Oregon. The River Forecast Centers are co-located with the weather forecast offices. We're with the Sacramento office. Other ones, like Salt Lake City, they're co-located with the Salt Lake Weather Forecast Office for the Colorado Basin. Our job really is about decisions of work. We've put information out there to help people make decisions, whether it's reservoir operators, whether it's people concerned about flooding. That's what we're all about. Even in the drought, we were busy with that, just trying to help people make decisions. So we have, if you go to our webpage, you get this map with the dots and the colors. I think most people are probably familiar with that. But so this is the area we have, and then our staffing isn't that large. We've only got 14 people. We actually have 2 vacancies right now. 6 hydrologists working on this, but what we have that they don't have at the rest of the 12 other river forecast centers are this partnership with the Department of Water Resources, a state agency, where they've got 8 engineer hydrologists that work directly in our operations. So that helps a lot. Like this winter, when we got into our endless stretch of flooding, we go 24 hours then, and we don't have that many people to staff, so that really helps with that problem, having those bodies. This is just a real quick conceptual diagram of what our model does, and it handles the water. There's it filters through different subsurface layers, and our model sort of conceptualizes that and keeps track of it. These different parts of the soil kind of water. What we almost look at it like these tanks that fill up at different rates and contribute to runoff at different rates. And then on top of all this, we have a snow model that keeps track of all the snow physics. So it accumulates the snow and then melts it off. And that's a really important component this year. So how did we get here, and what can we expect? We have such a variable year-to-year climate. We never know what we're going to get, whether it's El Nino or not. As we showed earlier, you could almost get anything any year. There's some slightly more likely outcomes based on the ENSO cycle. But, in the fall, every fall, it comes up, we know we're going to, we got a winter season coming, we got to prepare for flooding, no matter what kind of year it is. So, we know winter is coming, but we didn't know we were going to get this, this winter. So, winter came this year. I won't bludgeon you with the 8-station index. We've looked at that. This is something off our website that you might be interested in. It's a little hard to find, but it's great information, I think, for people looking for context. And this is the seasonal historical flow. So every year, the April to July volume runoff for the American River at Folsom. And you can see this is the projection, this red line for this year. And you can see it's up there. It's high. It's not the highest we've ever had, but it's respectable. And you can get a table. You can at this table below this graphic, you can rank these. And so if we rank them according, we've been ranking them according to the driest. Now this year we're ranking them according to the wettest. And we have this year, it's number 16. It's up there. There's some places though that were pretty much number 1 for this year. As Cindy talked about, we have, because of all the water we got we have this issue with continuous water in the Tuolumne River going through Modesto. This is back from February through today. The flows, this is the flood stage. So they've been managing that. Of course, it was way above flood stage at one point, but they've been managing it to keep it just below flood stage to get this Don Pedro Reservoir down. And, it got up pretty high. And it's coming back down, but it's still encroached into what they call their flood conservation space. There's still a lot of snow to come down and melt and flow into that reservoir. And then farther downstream at Vernalis, the channel capacities aren't that high down here. So you get maybe 30,000 cubic feet per second is all it can handle. That's the real issue with the San Joaquin. In the Sacramento system, we have a lot better conveyance, with our bypasses and whatnot, hundreds of thousands of cubic feet per second we can handle. So that's been this issue at Vernalis. It's just been, they're finally getting down now to the monitor stage, which is where that's the level where they typically start to patrol levees. And so that's, we talked about the snow water equivalent snowpack. Basically, April 1st, statewide, it was 45.7 inches of water up there, 163% of average. We've melted some of that off. Now we're down to 35 inches. And just to visually show that, here's an image from April 1st of the snowpack. This is the snow water equivalent, the water in the snowpack, the snow depth over here, a pretty good pack. And that's what we have now. Some of it's melted off, but you can see there's still quite a bit to go. So in the spring, our parent agency forces us to put out this product that, it's real useful for this part of the country because it's, they get a snowpack in the mountains and they know what's going to happen there in the spring. It's a little early still. We're still building the pack at this time of year, and we kept building it this year. But we kind of knew we already had quite a bit, so we knew that some of where the problem areas were going to be this year. So what are the concerns this spring? I think everybody's well aware the swift cold water. That we've lost people that are not prepared for that, and that's one of the big problems we have is with that. But then the stress levees, Vernalis, in the San Joaquin, just that's had that constant water pressure on them. They're fighting boils and seepage, and that's problematic. And then we still have a threat of flooding to go in some areas.
Can I ask you a really quick question?
Yes.
If you go back, the swift cold water, because the snowpack is so huge, because normally we message that in May when we start getting the warmer weather, but do you foresee this being a problem into through June even?
Yeah, I'll talk a little bit more about that, but yeah, it's because of the large snowpack in some areas, it's going to keep going all the way till, in the Eastern Sierra down into Reno, Carson City, those areas might be into July with high levels, but there'll be flows everywhere running higher than normal this summer. So what are the concerns this spring? Well, kind of the elephant in the room maybe that we have is this, this Oroville, right? And spillway that is a little complicated with dealing with that. But the main issues we're going to have with that right now, we believe, are, like today, they're starting to increase releases again. And, it could put more water in the bypasses. So that impacts agriculture this time of year that they normally expect to be cultivating and planting. And also, you just higher river levels in Discovery Park, it's coming back up again with higher releases. This is kind of our water resources page on our website where you can go through and you can kind of get a briefing. You can get images of all the precipitation, snow, observed flow, reservoir storage, all of this available. And I'll step through that when I finish this just to show you kind of a sampling of some of the products out there for you. But contact information, we have, if you're interested in all the weather stuff and hydrology, they deal with that too, especially the warning part. We don't issue the warnings at the river forecast centers. The weather forecast offices actually put out those warnings. But you can contact them. They're a 24/7 operation. We're not necessarily unless it's flooding. But here's my contact, and we'll distribute a better contact sheet for you after this. But this is something, just for now to kind of illustrate the different sources for In California, we do water supply forecasting at the River Forecast Center, but official forecast that most people use for their operations and then so forth is done, produced by the California Department of Snow Surveys. They, they dig their samples every month and measure it, and we use that information too to kind of true up our snow model. But it's pretty much once a month an update, and they do update weekly on that. Our forecasts kind of show you what's happening every day, which is noisy. It goes up and down because we're kind of seeing a little bit into the future what's happening with the weather and taking that into account. If we get a big atmospheric river event, you'll see the water supply amounts forecasts go up because we got to account for that. And in the past few years, if in January for the next 2 weeks we have a big ridge of high pressure, we're normally expecting rain, and then our supply forecasts start to go down because we're not getting that precipitation. And specifically, so if you have snow questions, they have a list of phone numbers by individual. They don't have a central number, but you can call. Dave Rizzardo is the chief of snow surveys. You can get him, and all the numbers are listed there. And then here's contact information for Oroville information for our big elephant that we have.
Hey, Al.
Yes.
Just one thing, a couple things to note on the snow surveys. It should be CBEC.
Oh, yeah.
Oh,
Okay. Yeah, thank you.
And then the Oroville contact information. This is a newly set up information line and email that I'm sure you're aware of the public meetings at Oroville, or the PWR is conducting. And they've been sending this out for the public to use. But they'll have information, you guys have just general informational questions.
And then
I did pull up. Yeah, if you go there, I pulled up the RFC. Yeah.
All right. So that's everybody familiar with our main page, I imagine. So the colored dots, all that. What you might not be quite as familiar with, and I could, you may be, but I don't know, is this water resources. That's what I was just showing you, that one graphic there, where you can go through and look at, all the different things. You can see that, well, boy, for the water year, we're kind of off the charts with extreme above for what's fallen. But you can look at snow information. This is what our model is simulating for the snowpack there. You can kind of see it.
There's a breeze, but
Alan, go back to the one you started with and just give us a brief explanation on what all the dots meant.
On this one?
If you can. No, the one you started with.
Your front page.
oh yeah, what'd you spell?
Oh, I'm sorry.
Not there. You meant from the from here?
The
water resources.
The water resources one. Okay, so
where it
that's
had like polygons and squares and circles
Yeah.
and triangles and everything.
all blue.
Right.
Yeah.
What is that telling us? The
So-
bigger the. I mean, I don't think it's real intuitive, so maybe you can explain it to us.
okay. Yeah, these are the forecast water year volume. So this is from October 1st to September 30th for each of these locations. Most of that's already occurred, but there's still some precipitation that'll come. And this is just telling you what, for each of our forecast points that we do these probabilistic forecasts for, what the expected outcome is. And it's basically more than 150% of normal is the amount of precipitation for the,
Do the size of the dots mean anything?
or the volume, the runoff for
That's just
the water
size
year.
of the water. It's not like a historical size of it, I guess, right?
No, the size of the dots, let's see, what is that? Those are, yeah, there's some areas are going to produce, 150% of normal. Well, some normals are bigger than other normals. So the big dots will
So
be,
they're scaled to the total
yeah.
volume.
Gotcha.
and these squares that you see here, those are fairly new, just they've been around for a few years. What these are, they represent the cumulative, the four rivers in the north and the four rivers in the San Joaquin. So the Sacramento, the Feather, the Yuba, and the American, all as one entity. And then so you can look at it as a basin as a whole. And then for the San Joaquin, it's the Stanislaus, the Tuolumne, the Merced, and the San Joaquin. So those represent that. That's useful for getting a picture of the whole basin, the runoff. So that one's pretty
I
big.
think so.
Yeah. But this, what you'll want to do is maybe do some exploration here, but there's some good information. And one of the things I wanted to show was forecast flow. If we look at the spring peaks, a map of the peak flow dates. So this is when we're expecting the highest runoff, the highest one-day runoff is going to be somewhere, there's a window of time, right? But these are generally we expect it up here where the elevations aren't so high. You don't have all that high elevation snowpack. It's going to run off sooner, so we may have already had our peaks, or they're going to be fairly soon. In the higher elevation of the Sierra down here, the high elevation cold snowpack takes a little longer to melt and reach its peak. So those are more like early June, it looks like now. And some of them even on the east side here, late June almost.
That's a cool graph.
Yeah. So just realize that that's kind of the estimate of about when we expect it based on what we have and what we're able to see going forward with temperature forecasts and whatnot.
Is there like a climate statistics for that would also show what the averages are for those?
That would be a nice thing to have, and I don't think we've developed that information. But yeah, but again, it's pretty variable, depending on the snowpack you have.
But on a typical year, usually the Sacramento system, of course, always peaks earlier, and it's usually late April. And then the San Joaquin system on a year not this big, it's usually mid-May is what I've observed. Don't quote me on those, but the idea is with the larger pack we're running much later, and peaks will be later in the year.
Yeah, a year like 2 years ago with 5% of the snowpack.
Okay, fine. Late in March.
This one was, so there's outliers, and you take all the outliers and you get an average, kind of in California, right? So,
Yeah.
yes.
On those dates, what's the window, like the peak flow, maybe week or days, or is there like a range around those dates that you're expecting the peak flow?
Yeah, if you really want to dive into this,
Or just, I don't know if there was like a rule of thumb.
it's about maybe 2 or 3 weeks or something like that.
Okay, so kind of
Typically,
around
yeah.
that date.
So we might, okay, well, at least this shows up. So this is for like reservoir operators use this kind of information. It's a block of 4 or 5 day periods, and there's a reason why it's 5-day blocks, but I won't go into that here. The math works out, I think, for the translating the volumes to something. But this, down here, it'll show you the 1-day peak stream flow volume observed so far was April 19th, 56,000 acre feet. The peak 1-day stream flow runoff, pretty much in a couple days here, May 12th, and could be as late as June, 10% probability kind of, or as early as right now. This could be that we could have already observed the peak, basically. So this is, for when you get into the snowmelt season, this will kind of give you that window of when we might expect it. And then for the historical context, that's these historical flows. That's that graphic I showed there that shows you can either plot it by water year or seasonal runoff, and that's the volume for that time period. And the forecast, wherever we're at, and through the end of that, either April, July, or all the way to the end of September, forecast will show up there, and that includes whatever's already happened too. So you can kind of do things, and then this table shows up below where you can rank things. And if you just click on that, you can get, if you want the, because it's listed numerically by year, but if you want it by the flow, there's the driest ever. That's what we were doing. Like I said, 2015's in the top there. And if you toggle, it toggles back if you click it again to be the wettest ranked, and that's where we're down here at 6. Where are we?
Number 16, I believe.
16.
You're on
27.
Never mind.
Okay.
You're on, oh, yeah.
You're just on Folsom.
Okay. So their annual flow.
But if they want to dig around more, you'd be the contact. if you
Yeah,
have
that's
questions.
that you can if you want to get it, just to let you know this information is available, you can call me and ask more about it. Do we want to take questions now, or?
Do you do any work at all with groundwater or network at all with that, or is that just totally separate?
No, that's pretty much a separate thing. We're surface flows, but the USGS is a good contact for that kind of information.
And the
And-
Department of Water Resources.
Department of Water Resources too.